Okay, in this presentation we are going to look at continuous random variables. Suppose we have the random variable x, which has the following probability density function, f of x, well, that f subscript x of x, that's how we would denote the probability density function. Anyway, that is equal to 2 over 5 times 4 minus 3x, where x is between 0 and 1 and 0 otherwise. Okay, what we're asked to do is complete the following exercises. Determine the cumulative distribution function of x, which is to say capital X subscript x of x. Okay, it's easier to see it and recognize it than verbalize it. That's a capital X. The probability density function is a small capital F, and probability density function is small f. Anyway, so calculate the median of this distribution, and then calculate the 25th and 75th percentiles, and then hence calculate the interquartile range. Okay, now, so first off, what we're going to do is make this little remark about this integral here. The integral of 2 over 5 times 4 minus 3t dt equals 8 over 5t minus 3t squared over 5 plus c. So just sort of have that in the back of our minds on an ongoing basis. So the cumulative distribution function, capital F of x, is essentially how calculated using the following. Okay, so it is the integral of f of t dt evaluated from 0 to x. Well, put it this way, the lower bound of the range of values here, all the way up to x. Now, we don't use f of x, and we don't denominate the probability density function in terms of x, because we want our answer to result in a variable that is an expression in x. So that's why we'd use something else instead. In this case, it will be t. So essentially, when we do evaluate our answer, we're using x as the upper bound of the integral, the upper limit of integration, then we would have an expression in terms of x. The lower bound here, 0, is just influenced by the fact here that this is 0, this value here. Okay, so it's 0 otherwise. So from minus infinity to 0, the integral just evaluates to 0. So we can just disregard that. Okay, so we're allowed update our limits of integration accordingly as to sort of suit what is here in these range of values. Okay, and it's an important thing that beginners might not be familiar with. Okay, so using the integral, capital F of x is equal to the integral from 0 to x of 2 over 5 times 4 minus 3t dt. So that is our integral there. We can disregard c there. So when we evaluate that out, we have 8 over 5x minus 3x squared over 5. Okay, so the complete specification of the cumulative distribution function should look like this. 0 where x is less than or equal to 0. This expression here, 8 over 5x minus 3x squared over 5, where x is between 0 and 1 where x is greater than or equal to 1. Okay, that's the full specification there. And I think really in a lot of cases an answer like this is what you will need to get full marks. Okay, so the whole thing there, not just this part, you need the full thing. Okay, and again, just get used to using the proper specifications of the range of values there, like x less than 0, x greater than 1. What happens in these cases? Just give the complete picture there. Okay, so x tilde, as we say, I'm just going to call it the median. This is the median of the random variable x, and can be determined by evaluating the value of x that solves this integral. So that's not exactly well phrased English. Okay, so essentially what we do is let our integral evaluate to 5, okay, 0.5, and then find out what value of x will sort of solve this. Okay, now we're going to have a quadratic expression here. When we work this out, it will result in this expression here. 8 over 5x minus 3x squared over 5 equals 0.5. Now, essentially what I'm going to do is re-express that, and it turns into a quadratic expression with the following roots. Okay. Now, so let's evaluate both of these. Essentially, this would be the minus b formula here. Minus b plus or minus is b squared minus 4ac all over 2a. And that will give us this expression here. When we are these roots here. Now, we evaluate both of them. X equals 0.3615 and x equals 2.305. Now, the thing about it is the probability density function is only valid in the range of values from 0 to 1, so essentially we can just disregard that. Okay, so the median is 0.3615. And finally, what we have to do is calculate the interquartile range, and the interquartile range is Q3 minus Q1. So using the very same approach as we've used in part B, what we're going to do here is set up two expressions here, and we're going to same approach really, just let it equal 0.25 and 0.75, the integral that which integrating the cumulative distribution function, or it's essentially using the cumulative distribution function essentially, letting it equal to 0.75 and finding the value of x that will give us that value accordingly. So using the roots formula x for the Q1, the 25th percentile, that would be x equal 1 over 6 and x equal 5 over 2. When you get the roots of that expression there, this one here, and that works out to be x equals 0.166 and x equal to 2.5. But we could disregard that one because it's outside the range of values. So Q1 is essentially equal to 1 over 6. Similarly, x equal to 8 minus the square root of 19 over 6, and x equals x equals 8 plus the square root of 19 over 6. That will evaluate as x equals 0.6068 and x equals 2.05981. You could disregard any values outside the range. So what we have there is Q3 equals 0.6068, let's say, and subtracting one from the other, I didn't write out the answer there, the interquartile range, IQR, equals 0.6068 minus 0.1666. Working that out, we shall get 0.4298. Okay, 0.43 essentially is the interquartile range. Okay, that's grand. We leave it there. Okay.